Module 5, Review and More Divide and Conquer approach. We have a few more small topics left in Module 4, Divide and Conquer, but we already have 5 parts. So I like to start a new module to complete the remaining part. But the most important thing we need to do now, review for the midterm. So the part 1, we will do that review. Review for quiz 3 and homework assignment 1. 8.1, review for quiz 3, part 1, the first 5 questions. The first question, if we can solve a computing problem using both iterative and recursive methods, which one uses more memory resource in general? In my video explanation, I explain this part. Because if you look at the internal implementation of recursion, you will see inside the memory, a special data structure is used. So that is the stack data structure. So we know the stack data structure is like this. There are many levels. So you push things down, based on the order. First in, last out. So it's main property. First in, last out. That is its main property. A stack uses a lot of resource, memory resource. And if you need to implement the recursion, you may need to use a very deep stack. A stack could be very deep. The deeper the stack, the more memory resource is used. But for iterative method, we don't need to use stack. Iterative, basically we use temporary variables, and those temporary variables can be reused. When we reuse those temporary variables, we can save a lot of memory resource. So based on that background, so you can see, so which one use more memory resource? Recursive method. Some of the students may not watch that part of the video, so that background. Here you can see my quiz questions are mainly designed to check. Part of it, I want to check if you really pay attention to the details when you watch the videos. So this question is one of those. All right, next question. All right. Oh, yeah, I have to erase. Yeah. All right. Which of the following category does the recursive algorithm we use to solve the Tower of Hanoi problem belong to with respect to number of disks? And check if you know the formula. Remember, at the end, we solved that linear recursive relation. The answer is pretty simple. 2 to the n minus 1. When we need to move number of n disks in that Tower of Hanoi puzzle, we need to use this many disk moves. That's the answer. So if you know that, you can easily find. So option 3 is the answer. Next one. Question number 3. Which of the following categories does the recursive algorithm we used to solve the count binary digits problem belong to with respect to the given number n? The formula we derived, right? So we consider a special case, n equals power of 2 first. Based on that structure, then we guess the formula. right? So 1 plus floor function log base 2 of n. Okay. After that, we use mathematical induction to prove it is correct. Okay. The proof pretty long, not that easy. Yeah. But here you just use this formula. Okay. So that one minor term we can omit. Floor function, only less one difference we can omit. Yeah. So the answer, big O of log of n. Yeah. Although here we use big O, but if you want to say big theta of log of n, also correct. Both upper bound and the lower bound. Yeah. The reason many times you see people use big O more because people feel, easier, right? The big O more popular than big theta. Big theta more precise, but big O, so people just feel easy to use. Yeah. All right. Next question. Question number 4. When we solve a computing problem, if we can guess the result, that is very close to the real result. Yeah, that's not easy. Yeah, really close to the real result. It will be very helpful for us to solve the whole problem in a lot of situations. Yeah. So this statement, I talk about it in one of the videos, and that video, I talk about important strategy, guess and verify. All right, so in problem solving, so this strategy is used a lot. And many times it is very effective. Yeah. Why? The reason is very simple. If you can get a pretty close guess to the real result, then what do you basically need to do? Just to verify that result is correct. Although you may find some small errors, you can make an adjustment easily, to make it exact the real result. But if you have that goal there, you can see it. So that's the result I want to get. Then many powerful mathematical tools you can use. For example, mathematical induction is one of the powerful tools you can use to verify your guess. Yeah. So this view I explained in that video. Yeah. So you need to watch all the videos. Yeah, but I noticed many students didn't watch. Second, when you watch the videos, you need to think. You need to learn the ideas. Yeah. So that idea is important. That strategy, guess and verify, that strategy. Yeah. All right, so the answer is true. Yeah. Last question of this part. Yeah. Smooth function. Is the function 3 to the n a smooth function? Now, here, I hope you use the definition to prove it. Okay? Yeah. The definition is, so here, f of n equals this given function, but we need to show f of 2n. If we can show, if we can show f of 2n belongs to big theta of f of n, then it is smooth function. Okay, yeah. So that is the definition. Yeah. All right. So here, can you show f of 2n, 3 to the 2n, okay, yeah, equals 9 to the n. Definitely you cannot show it belongs to big theta of 3 to the n. The reason is very simple. Okay, the reason is very simple. Just look at the limit when n goes to infinity. 3 to the n over 9 to the nth. After simplification, 1 over 3 to the n. When n goes to infinity, it equals 0. Equals 0. So that means the denominator dominates the numerator. So how can you say big theta, right? So big theta, you have upper bound, lower bound, right? Upper bound, lower bound. So you cannot get this limit equal to 0 case. You cannot. Yeah. So that means this function is not smooth function. Okay? All right, so we complete part 1.